Now, good evening. So we will go with NPTEL assignment 5 and we have part 3. Already we are with problem number 7 and now we will go with problem number 8. So now here we have to calculate the vertical displacement at D. EI is given here now. So EI we will get it as 2 into 8.33 into we have 235 and 611. Newton mm square, and that will gives us 2 into 8.33 into 10 to the power 2 kilonewton meter square. Now we will start with, we have to go again same, we have region, we have origin, limit, then we have EI same, so I will not write here m and then small m. So now first we will go value of the reaction. Now we will have horizontal reaction over here and UDL will give clockwise moment, so it should give anti-clockwise moment. So here we are in this way. So now if we will take moment about D0, then we will have 0.1 into 10 into 5 and that I will say HA. So minus HA into 8 and that is equal to 0. Sorry, that is 0 already we have mentioned. And therefore we will get value of HA that is equal to 5 by 8 and that comes 0.625. So now this is 0.625 and this also we have 0.625 because equal and opposite. So we have vertical reaction here only and that will be 0.1 into 10 and that will be 1 kilonewton. So these are kilonewton. Now we will start with first AB. Now this 0.625 is actual, will not be considered origin A. Limit we have 0 to 10. Value of M we have x minus 0.1 x square by 2. Then we will go with DC region. So DC region we have, this is axial force. So M for DC region is 0. And therefore we need not require to consider DC region. So now we will go CB. Origin we will take C, limit we have 0 to 8. And moment we have 6.25 into x anti-clockwise, so plus 6.25x. Now we have to find vertical displacement at D and therefore we have to apply unit load, vertical unit load at this point. So I will apply unit load over here. So we have this as 1 over here. And then automatically we have 1 over here. So here we do not have any force. And now we will go with M. So in this portion, we have simply 1 into x. So this is x. Now what will happen in this case? So we will have in this case that value that is equal to 1 into this distance we have 10. So we have directly 1 into 10 in this anti-clockwise. So we have this value directly 10. And then we will go delta at D that is equal to 0 to L M into M dx upon EI. And now we will go separate part. So we have first 0 to 10 x square into dx upon EI. Then we have minus integration 0 to 10 0.1 by 2 into x cube dx upon EI. Dx upon EI, and then we have this last term plus integration 0 to 8 6.25x into 10 into dx upon EI. Now if we will calculate these values separately, then we will have this value, that is 1000 upon 3. So x cube by 3, we will get it as 1000 upon 3. Then second value we will get it as minus 125, and third value we will get it as plus 200. And if we will solve this, so we have EI in all these upon EI, upon EI, upon EI. And then if we will solve this, then we have 1000 upon 3 plus 75. This goes to 408. Now we will go for integration alpha x square comma 0 comma 10. We will get 1000 upon 3. Then we have integration 0.1 by 2 alpha x to the power 3 comma 0 comma 10. This comes minus 125, and then we have integration 6.62.5 into 10 comma 0 comma 8, and it comes 6.25 integration 62.5 alpha x comma 0 comma 8, and we will have this value that comes actually. So this is 0.625, sorry, this is 0.625, and so this is 6.25. 10 need not require to consider, and this value then comes 200 upon EI, and then we will have this value, that is 1000 by 3 minus 125 plus 200. It comes 408.33 upon EI, and EI we have 408.33. Now this is in meter, convert it into millimeters, divided by 2 into 8.33 into 10 square. And if we will calculate this, then we will have this value, that is equal to divided by 2 into 8.33, and it comes 245 millimeters. So we have this value as 245 millimeters. And option we have B. So option we will have this B, 245. Then we have ninth problem. So in this we will have to find out displacement at A. Now first we will find this reaction. So we will take moment about C0, and then we will get equal to minus 1/2 into 25 into 10 into 10 by 3 plus RB into 10, and that 0 already we have shown. And from this we will get RB, that is equal to, so 1 10 10 will get cancelled. 10 10 gets cancelled, 1 2 10 get cancelled. So we will have this as 10 10 get 250 divided by 2, and then we will get RB, so half into 25 into 10 into CG we have 10 by 3 plus RB into 10, and that is equal to, sorry, RB into 5, not 10, because RB here and this distance is 5, and that will gives me, so 5 2s are 10 10 gets cancelled, and we will have 250 upon 3. Moment we are taking about C, and therefore it should be RB into 5. And now knowing this, we are going to be with again region, then we have origin, then we have limit, then we have M, and then we have small m. So I will repeat here. So M and that we require more space, so I will take a remaining part on this side. So this is limit, and then we have m, and then we will go for small m. Then region first we have, that is AB. Now origin A, limit we have 0 to 5. Now what will be our value of moment? So we will have this as y, let us this is x. Then we will have y by x, that is equal to 25 by 10. And from this we will get y is equal to 2.5x. And then what will be bending moment? If I will consider now this triangle, so I have this value as 2.5x. This value we have x. And then we have mxx, that is equal to 1/2 into x into y into x by 3. And then this we will get it as 1.25 into x cube upon 3, or 2.5 x cube by 6, one and the same thing. So I will get it as 1.25 x cube upon 3. And then we have second region, which will be BC. Now origin we have B, limit we have, now I will put it as 5 to 10. Why I am putting 5 to 10? So that my this equation will remain as it is. There is no change in the equation. So this I will get as it is, 1.25 x cube by 3. And then due to this reaction we have minus 250 by 3 into x. So this will be my value of m. Now we have to find out small m. So we will have this, and we require displacement at A. So we will apply 1, and from this we will calculate RB. So we will take moment about C0, and from this we will get RB as 2. And now m, small m we will get, in this region we have 1 into x, so that is x. And in this region, so if x is from here only in both the cases, sorry, in this also we have a origin, that is A, and therefore we have taken 5 to 10. And now in this we will get it as 1 into x, so this will be as it is, minus, we have this is 2, and this distance we will have x minus 5. And then we have minus 2 into x minus 5. And if you solve this, we have x minus 2x plus 10, and that will gives me 10 minus x. And then I will solve this. So delta at A, that is equal to integration 0 to 5 1.25 x cube upon 3 into x into dx upon ei. Then we have second this term, so we have plus integration, now 5 to 10 1.25 x cube upon 3 in bracket 10 minus x dx upon ei. And then we have next part minus integration 5 to 10. Then we have 250 upon 3 into x into 10 minus x dx upon ei. And then if you will solve this, then we will get these values, that is equal to, first value we will get 260.41 upon ei. Second value we will get 1692.71 upon ei. And third value we have minus 1736.11 upon ei. And if we will solve this, then we will get it as, so just we will solve this. So we have 260.41 plus 1692.71 minus 1736.11, and we will have this as 217. 217 upon ei, and we have option as B. So we have option B. And then we have last problem. that the bending moment diagram of beam is shown in the figure below. Which one option be the correct support and loading for the beam? So now it is very clear. Here we are going to be simple support. Here we have UDL. Now in this case, as we have bending moment 0, so here we have roller support. Now which will be the correct option? So we can have this. So this will not be possible. So then we have concentrated load. This also not possible. This also not possible. So this cancelled because we have fixed end moment. Here value is 0. This is not possible because we have concentrated load. This is not possible because your moment is going up. And therefore we will have this as a continuous beam, because if we will go for this, then our bending moment diagram should be in this fashion somewhere here, and then it will be like this. So we will have option as A because this is continuous, and then we will have this will be option A. So likewise we have to solve the problems. So today we will stop here only. So thank you.